Okay, so tonight tonight we're gonna continue, I guess, looking at oh wait, no, that's not the window I wanted. Um at kind of how to get the metadata in the proper format for the um for the final data set, and also looking at what else we need to add to the data set in terms of data sources. And so one of those is soil moisture. So we have kind of added some of the snowpack data. We're also looking to add soil moisture, and that's probably going to come through this scan network. So I haven't been able to find a good way of getting the soil moisture from scan, but basically from scan there are these reports you can generate. I'm not exactly sure how to construct this URL string, so I might just paste that there as an example URL. But basically the thing is we want soil moisture, because soil moisture is going to be useful for both predicting stream and river flows, and also for other data set uses, like say predicting wildfires or when to grow crops. So having kind of good soil moisture is also kind of interesting and important. So this person so yeah, it actually looks like this person was able to maybe figure out how to query the soil moisture from the scan network. So in this case, scan is from the USDA, and there are different sites for the scan network. So not sure where he's importing this from. Custom functions. So I think he created his own maybe package called custom functions here. Oh yeah, that's right. So it looks like most of the functions he created though are, I guess, from aggregate essentially aggregate items. So anyways, I'll plan that there. But then the other thing we're going to also look at is kind of begin to define the schema of the metadata. So we'll do that here. I guess maybe under here. we can put it. So what we're going to do is kind of create a schema for the metadata that we then put into BigQuery. So let's first take our metadata from here. So ideally what we'll have is basically, so this is, for instance, some of our metadata now. Oh yeah, that's why. So it basically, most of our metadata has like an ID for the station, a latitude and a longitude, a name, a state, etc. And then it has things like elevation and then other stations. So this is it in the JSON format. And then at the bottom it has these stations. So I think this, yeah, list of kind of both these stations, and then these are the ASOS stations. So I think what we'll do is we'll change that. So we're looking to then essentially turn this into more of a table format. So in the table format, I'm thinking we'll have an ID column similar to this, and this will be the station ID. So these will become kind of columns. And I don't know why there would be lat and longitude, but it would be like ID, lat, long, or in whichever order. So BigQuery 2 then does allow nested JSON. So we'll probably keep, definitely the soil data we'll keep as nested JSON, because that's kind of a big thing. This, I don't know if we'll keep this, since we're really converting everything to UTC anyways. And so something like this, state, and then stations, we need to think about how best to store these, whether we'd keep this as the nested JSON. And such like that. So I think right now we might then put the ID of the closest ASOS station. And then we could have a list of other ASOS query. yeah, maybe we could do like a list of then the remaining stations there. And then we'd also have something like closest snowtel ID, closest snowtel distance. And if these turned out to be like East Coast, we could fill these with like nan basically. Um, and then we're also going to have, I actually don't like that. That makes it more confusing. Closest scan. And then we'd also have a link to, so then we'd also probably want a link to, oh yeah. So when we actually scrape the images with Sentinel, we're going to store them under a path. And so this path will also be saved in the table. So yeah, it looks like you could do that. So I would then probably have, so the soil data will then remain the JSON format, and then we'd still have as an ordered list, it looks like, in the SQL. That way, someone could potentially also do a query and then join another ASOS station to this. And then, so that's how the metadata, I think, would sort out. Of course, then the actual stream DF would basically go by the ID. And then it would have, all of its temporal data. So yeah, I think that's kind of what it would look like. We don't actually have all this data in the metadata yet. But when we do, we're going to create a table. I kind of create a table like that and then use that table to run the queries. And then, yeah, I think we'll also, yeah, of course, throw some of this other data in there. I'm not sure. Scan reference map. Are there really only this many scan stations? So I guess we have to look more at where the scan are. I thought there was more than that. Oh yeah, we also want to do a way that we would have certain flags. So just yes, no flags. So this will be a fairly, I guess, wide table. So we'll do that. So, okay. So again, so yeah, basically you can have JSON in your BigQuery table. And there seem to be some utility functions for that. And that's obviously good because things like the soil grids, we'd want to keep as JSON here. This would obviously be a big pain, I think, to try to convert, so we just keep it that way. So again, we were working kind of with Terraform to actually create this infrastructure. So let's go into there. Oh wait, I think we made a different repo. Yeah, we made a different repo there. It was this one, right? Okay, so come on, it should not search from the fucking App Store. Always use Visual Studio. I always want to use this for this. So that's the buckets. We created that bucket a while ago. But I'm actually going to probably just copy all of this in order to create the data table. So so this is going to completely change. So right now we're going to look at creating a BigQuery table with Terraform. This schema is actually still probably going to change. And often the way you do this with Terraform is you can specify a JSON file. Is schema required? No, it doesn't look like it, so we actually don't need to specify that, but you would go here, you'd make a dataset name, etc., etc. So that's what we'll need to do when creating this kind of table. The thing is, yeah, I'm trying to figure out if it would make sense to do this now or later. Yeah, because might be better to do this actually later once we get the once we know more about the different once we get like the schema, I guess, more entirely fixed. This is still flexible, but the idea here is we're going to take this JSON, instead of having a separate JSON file for each gauge, we will have a JSON, just one table of the river gauges. So So this would be called something like river data or something like, I call it gauge actually. Gauge data meta. And this would be probably the table in our data set, the name of it. So, but yeah, we have to finish figuring out what exactly we'll need to take from this. I did find a way to pull data from other stations too with respect to snowpack data. This is one of the confusing things too about government data is there actually are a lot of different APIs you can use, and so sometimes it isn't actually clear which to use and which is best for a certain situation and how much these things overlap. Like I think this is related to ASOS. Or no, this is a coop station. So the idea would then, I mean, the Iowa site I think provides us, no, that's not what I want. With all the sites that are, the basically the ASOS sauce, whereas this site would provide some of these other sites that are different. So that'd be Cocoras or Coco. I don't know how to pronounce that. Coop and Waban. So I don't think there is actually any overlap between this and the ASOS. So these are called GCH or GHCN data. But when you click the link here, it's unfortunately broken. So I don't even know what exactly that means. But I do not think these are actually the ASOS sites. So, and each of these have different stations, though a lot of these stations seem to only report to on a daily level, whereas ASOS has always been hourly, which is more useful. Yeah. Nevertheless, some of these could be useful, for instance, getting the snowpack in eastern states where the SNOTEL is not available, or to supplement the ASOS with readings from these other stations. So, they do have an API, I think, and I'm gonna actually, probably it makes sense to more check these on GitHub to see if anyone has it. Um, Okay, but that only gets the station and metadata. It doesn't actually get the data. So I don't know how exactly that would work. So this is, no, this isn't scan. So yeah, I'm not sure exactly how that would work. So in any case, yeah, in any case, these things will all affect somewhat what the final schema would be. One of the good things I think about doing this with Terraform, though, is we should be able to just reuse our code and reapply things as necessary. So yeah, I'm going to actually then go back to that. Okay, so this is still talking about the storage bucket. So yeah, we'd use this code to essentially create the table and the data set. I think first, though, we need to create the schema file. Okay, so I'm just seeing now how to create the schema file. No, that's not what I want. Okay, so it looks like you'd use stuff just like this. Okay, so oops, I did not want to do that. So we just start with schema meta. Okay, that doesn't look right. Yeah, so I think it's just an array of these different blocks. So basically, yeah, we will actually have state. First and most important is probably ID. So So state, so this is actually kind of right already. Oh yeah, I also wanted to check. So I had merged the pipeline earlier. No, I don't want to use email. Fuck. Okay. So master I think should now be running actually too. Oh yeah, it is. From when I merged that. So that's good. Forget how I get the status badge though. I think we can just copy it, right? I mean, that's not oh yeah, there it goes. So we could just throw that up. Okay, I'll just throw that up. Even though it's kind of random. Yay, status badge. Okay. Anyways, where was I? Okay, yeah, writing the schema. So, what did I call that? JSON? Shit. That should not be called that. Now, of course, it's going to act like it's not found. When really it is. Okay, we'll get rid of that. Okay, that should be ID. ID, should it be a string? Well, some of these I do know have the lead 0. So those may need to be a string. In any case, let's just try to get the temple made. The table made. State, we can replace that with probably any of a million things, right? State, ID, state. So we could do latitude now. I think this would just be a float then. Yeah, I just need a I'm pretty sure a float will work. I'll do a float 64. And then the other thing we need to do then is, okay, well, we can just do this for longitude too. I don't think it actually need, what's it going to do? Yeah, I don't know what would be the best size for this. Let me go back and look at the document. So again, go ID, something like longitude, latitude, state, closest ASOS ID, and then these kind of filler things that ask about the closeness, and then the paths, and then the JSON. Let me see. In any case, so that's kind of the main of it for kind of building out the schema of what the tables will look like. The other table will, of course, be... The good thing is that at least once most of these sources are added, for the metadata at least, it's pretty much going to be fixed. It's not going to be updating on a daily or even probably a monthly basis. It's mainly just going to be fixed. So that's why it's important to, I guess, try to get it right the first time. We are kind of going to write kind of an ETL job, which will then create all these tables. And then, these linkages, others can also start to query too. So, yeah, so that was kind of the core of that. And then, let's just see if Circle CI is running. No real reason to believe it's not. Yeah, so looks like only an hour ago the refactor pipeline ran and succeeded. It's not a very complicated pipeline at the moment, but it works. So, and then okay, so bonus add soil messenger. Okay, so we're kind of working on these. We did, well, yeah, kind of work on that a bit. And we do have some of the things to append, at least the geological service data and a little bit of the international. Data. So anyways, so yeah, it's probably wrap up there for now. Has been kind of more boring day just looking at how this schema will form out and then how to actually create the table and then write to the table and then kind of allow then researchers to use both this table and even potentially other public data sets to do research and study, and then hopefully they'll also utilize some of the image or the models that will kind of store for easy download in the same project. And that will be like another bucket I think we'll add to Terraform soon. So, but anyways, that's kind of the core of it, of what we went over tonight. And be back tomorrow, I guess.